Enrico Fermi, reflecting upon the vastness of the cosmos, wondered how it was that we hadn't found evidence of extraterrestrial life. There were, it seemed, so many stars and planets, but still no sign of anything other than humans on Earth. Then and now, we're enduring what's often called the Great Silence. There have been various theories put forward, however, as to why we seem to be so alone. And although one might assume that the discovery of alien life would be a major and positive breakthrough in human history, there are some suggestions that it could actually be terrible for us. Enter Robin Hanson, an economics professor and contributor to the Future of Humanity Institute at Oxford University. Hanson in the 1990s suggested a possible explanation for the Fermi paradox, known as the Great Filter. The Great Filter theory states that there must be something that prevents life from reaching an advanced stage of development, that any intelligent life in the universe must first proceed through a ladder-like series of critical and developmental phases, but that one step on that ladder is extremely difficult or even impossible to pass. Therefore, it's only when life does pass that step that it can truly be deemed intelligent. The idea is that this crucial obstacle, whatever it is, must be far too high of a jump for most creatures and civilizations to make. And so it usually signals the inevitable end and regression of most life forms and civilizations. This is the Great Filter in action. But what could the filter be? To become an advanced interstellar civilization, there are some minimum requirements. First, there has to be a home planet. Then, if other alien species mirror evolution as we've seen on Earth, life itself needs to develop on that planet and spread. Then, the simpler blocks of life, such as unicellular organisms, must come together to form greater forms of life, such as multicellular organisms. These organisms must then evolve to reproduce to enable them to evolve some more. At our stage of life on Earth, humankind tends to take all of these imperative steps for granted. But it's only after all of this happens that we can even begin to build a civilization as we understand it today. Multicellular, reproducing, complex organisms must then invent various tools and use them to further advance their existence. Roughly here is where humanity is currently operating. One interpretation of the next step, however, is that a sufficiently advanced civilization must create advanced space travel technology, because that will allow them to take the next step and depart their planet, to colonize other worlds and star systems, and ultimately to avoid self-destruction. Of course, we know that humanity is actively striving to achieve space travel, and we've certainly made progress in recent decades, exploring the solar system and beyond with the development of robotic probes, reusable rockets, and radio telescopes. Yet, in all our efforts to launch machines and signals, we have, to this day, still received no response. We have every reason to believe that our universe contains many, many Earth-like planets, but we still have zero evidence of extraterrestrial intelligence. The Oxford philosopher Nick Bostrom has previously described the Great Filter as being like a probability barrier. How probable is it that a certain sequence of events should happen or not happen? How probable is it, for example, that the first building blocks of life emerge? How likely that they should spread, combine, and grow? And from that point, how likely that early intelligent life should advance to tool-using, city-building, jet-setting, tech-embracing, advanced societies? If any one of those stages is unlikely enough to be the Great Filter, then humanity has already passed it. And perhaps that's why we can't find other life forms. They're just not on our level. It's possible, however, that the Great Filter comes after all of that, and at some stage in our future. It could be an indirect event, an outside anomaly that results in the destruction of an entire species, an asteroid impact, a planetary collision, a passing black hole. These all could wipe out a planet or entire star system. And unless a civilization is advanced enough or spread out enough to withstand them, they will ultimately remove that civilization from space. Filter complete. It could also be a direct consequence of the advancement that any species makes, however, and the technology it creates. At this stage in history, for example, humanity is easily dangerously capable of self-annihilation through nuclear war. The rapid development of artificial intelligence, nanotechnology, and smart machines has also led to speculation on whether out-of-control tech could be what brings about our demise. Could these facts of modern life double up as Great Filter contenders then? And would that mean that to solve the Great Filter, we'd have to see our own self-annihilation play out? If so, it figures that it's possible that similar events may have occurred and may continue to occur throughout the universe, with other civilizations. And perhaps self-annihilation takes hold before any two civilizations can ever find each other. But still, the most important question remains. Has humanity successfully passed the test of the Great Filter already, or is it somewhere on the horizon in front of us? If we've already solved the Great Filter, it breeds the possibility that we as a species are a rare occurrence, and it would explain why we haven't found any other similarly advanced alien civilizations. We may be one of few, if not the only example of a species that has made it this far. We are special. If the Great Filter is ahead of us, however, it could well spell inevitable doom for everyone. Now we're imagining that life does regularly make it this far. It routinely evolves in a similar way to our own, sometimes gets to where we are currently, but that something still prevents it from going further and gaining an even higher intelligence. In this scenario, the chances are that we're almost certainly not an exception to the rule. That something will happen to us, and we will also be filtered out of existence. In this context, we can return to the search for extraterrestrial intelligence mentioned at the top of this video. With regard to finding alien life, Nick Bostrom says, quote, "No news is good news." This is because, from some points of view, even the discovery of simple bacterial life on another planet would be a huge blow for humanity. It would immediately make it so much less likely that the Great Filter is behind us. Not unless, against all odds, both us and our recently discovered alien civilization had achieved the improbable and passed it. We could no longer hope that humanity had beaten the filter simply by being here, by getting this far, and instead we know that the test was most likely still ahead of us. The same test that has seemingly ended all the alien civilizations that, try as we might, we cannot find. But there is still hope, even in this scenario. If the Great Filter isn't behind us, it's still possible that life anywhere remains at an early stage, and that humanity could be leading the charge. Since the time of the Big Bang, we may still have developed at a greater pace than most. And that's why we're yet to discover any other advanced civilization in the universe. In this version of events, the Great Filter is coming, but it's still coming for all of us, and only time will tell who will pass it and whether humankind will make it through. Clearly, there are so many interpretations. But regardless, the Great Filter does provide a potential solution to the Fermi paradox. And if it is lying in wait for us, then we'll either succeed or fail, survive or succumb. Solving the Great Filter could represent the single greatest achievement any civilization could make. But it could also signal the end of days. Which do you think